All right, let's go ahead and solve the differential equation by finding an appropriate integrating factor. So let's go ahead and start with the first one. So I'm going to first distribute that y inside. So xy plus y squared plus y dx plus x plus 2y dy equals 0, where this is my m, that is my n, and let's go ahead and take m sub y. When we do that, we're going to say the partial derivative of n with respect to y is just going to be x plus 2y plus 1, and then the partial derivative of n is going to, sub x is going to be, with respect to x, is just going to be 1. So obviously those two don't equal each other. So now let's try to see if we can find an integrating factor. So let's go ahead and say, well, mu is equal to, and we'll try the first, the exponential, where we suppose that we just have x's in our mu. So then we're going to have e to the integral m sub y minus n sub x all over n dx. Sure that's good, yeah. All right, and so now we're going to substitute in. So mu is equal to e to the integral m sub y is going to be, that changed? Yeah, the color's not too noticeably different. Okay, so x plus 2y plus 1, and then we're going to subtract in, so minus 1, all over n, which is going to be x plus 2y dx. When we do that, we get e to the integral. We're going to get x plus 2y divided by x plus 2y dx. So it's just e to the integral of dx, which when we integrate, it's going to be e to the x. So now what we're going to do is we're going to multiply our m and our n by mu. And so now we're going to have this new equation where we're going to multiply our m by mu. So we're going to get x, y, e to the x plus e to the, or let's do y squared times e to the x plus y times e to the x dx plus x e to the x plus 2y e to the x dy equals 0. Again, this worked well because, again, we eliminated just that one variable, x. Again, you know, if we try the other method, would we have been able to do it? It's not looking like we would be able to cancel out both methods if we were to choose to, you know, make it y. All right, so that's why it's important. So if you do it, notice that both don't cancel out, then okay, I can try the other method. So here's our new m and n. We can check it just to save time. It works. And so now we're going to solve this like we solved all the other ones. So what we're going to do is we're going to say, well, then our f of x, y is equal to, and, you know, let's go ahead and just work with the one on the right because there's less stuff. Actually, yeah, let's just go ahead and work with the one on the right. So we're going to take the integral of n this time with respect to y plus h of x. So the integral of n is going to be x e to the x plus 2y e to the x, and we're going to do that with respect to y dy plus h of x. All right, we work on this. We're going to get x, y, e to the x plus y squared e to the x plus h of x. And this is what our function equals. So now what we want to do is let's take the partial derivative of f, but with respect to x. So we're going to take the partial derivative of our function right there, but with respect to x. When we do that, we're going to have a product rule. So the derivative of x is just going to be y e to the x plus the derivative of e to the x, so xy e to the x plus the derivative of e to the x is just e to the x of y squared e to the x plus h prime of x. And that equals to what m was. And m was x y e to the x plus y squared e to the x plus y e to the x. And lo and behold, everything is going to cancel out. So that y e to the x is going to cancel that y e to the x, x y e to the x is going to cancel that x y e to the x, and then y squared. I'm going to erase that just so that people can see that in the notes if you just want to look through the notes. It's equal to y, integrate both sides, integrate the left, integrate the right with respect to x. We get h of x is equal to just c. So our differential equation is just going to be x f of x y is equal to xy e to the x plus y squared e to the x plus h of x, which is just c. So that just equals c, and it looks like we are finished. Box it up.